electrical component and explain how you identified the component in fig on the graph and fig 7.1. Right, so this is definitely a diode, right? Can call it a semiconductor diode. Semiconductor diode. Right, a diode can only conduct in one direction. So at some point the voltage, when you reverse the voltage, the component, it will not conduct. So that's probably how we identified it. Probably that's how we can identify it. If it's reverse bias, when you use the other side, then it's not going to conduct. A diode only conducts in one direction. So when the current is zero again, you can always get 0 volts. So you realize that from this side, there is nothing there, right? Because it's reversed, reverse bias, right? A diode conducts in one direction. In the reverse bias, it does not conduct. Okay, draw the circuit symbol for this component, right? We're looking at something like this with a bar in front, right? Usually this is the positive side and this is the negative side of that semiconductor diode. Fig 7.2 shows an electric circuit for two identical electric heaters. So this is also important because whatever happens, there is going to be shared in half, right? A and B are connected in the mains of 230 volts. So since they're in parallel, it means both of them, they have 230 volts across, right? S1 is closed. So if S1 is closed, it means that the current through this guy, all the current is going to pass through A. So that means you'll have 3.9 amps there. Calculate the resistance of the heater. So we use Ohm's law. Okay, so since we have V equals I times R, that means R is equal to V over I. And then you can see from here that we are using V as 230. This is divided by 3.9. What do we get from here? 230 divided by 3.9. Right, we get 58.974, and this is approximately equal to 59 ohms. To two significant figures. Calculate the energy transferred by the heater A in 5 minutes. So probably first we need to see how much power is generated through that heater. So power is equal to, power is equal to current times the voltage. So the current is 3.9 and the voltage is 230 volts. So this will give us 3.9 times 230. We get 897 watts. And then from here we know that P is equal to E over T, right? That means E is equal to power times time. Okay, then we have our E being equal to 897 times the 5 minutes has to be converted to seconds, so this will be 5 times 60. So now we have 897 times 5 times 60, Right, this will give us 2000. All right, 200. Let me see, what's that? Failing to read this anyway. 69100. Right, that's 269,100 joules. Right, to two significant figures, this is approximately equal to 270,000 joules. Right, so this is 270 kilojoules. Okay, that's what we have there. S1 remains closed and S2 is now closed. Determine the reading on the ammeter. Show your working. So since those heaters are identical, you can always go back and check there, right? The heaters are identical. So once this current reaches this point, it's going to be divided into two. So I simply saying 3.9 divided by 2 there. Right, 3.9 divided by 2. We are dividing this by 2. So what do we get there? 3.9 divided by 2. Get 1.95. So each one of these will get 1.95 amps. Right, so since the question said, so we're saying I through S heater 2. I in each heater would be equal to 3.9 amps divided by 2, and we're getting 1.95. Wait, where is the ammeter reading? Did I not make a mistake here? I'm sorry about that. Okay, so what we need to do here, right. Let's check the amount of resistance. We already know that this guy has got 59 ohms. Okay, this is 59 ohms, and then that is also 59 ohms. So we first need to calculate the effective resistance in the circuit. Okay, so let's find the effective resistance in the circuit. Since they are in parallel, that was a very big mistake. Okay, since they're in parallel, we're saying R total is equal to 59 times 59 divided by 59 plus 59. What does this give us? That is 59 squared over 2 times 59. This will give us 29.5 ohms. So this is now the effective resistance in the circuit. So from there we say current is equal to voltage over resistance, which is 230 divided by 29.5. So that means our I will be equal to, right, 230 divided by 29.5. The current is going to double, right, which is 7.7966 amps, and this is approximately equal to 7.8 amps.